So today I'm going to solve a system with three equations, a system of equations that has three equations, three unknowns. And the way I like to do this is a little different than most math books. So if I were teaching this in class, I would come in and I would put this on the board and I would say, okay, everybody solve this system. And most people look right here and they say, well, z equals 5. Okay, z equals 5. And that's an answer. And they didn't have to really do any work. And then they come here and they say, wait. If I put that answer here, I only have one unknown. So then they come over here, or a lot of times mentally, they just kind of do this in their head. And they say, okay, this second equation becomes that. This second equation becomes that. Y minus 5 equals negative 3. Add 5 to both sides, you get y equals 2. And so they say, oh, okay, well, I found that answer. And then they take this first equation here, and they say, okay, x plus 2y, well, y was 2, and then plus z equals 10. And they say, okay, well, 2 and 2 makes 4. 4 plus 5 makes 9. You move that over, and you solve that, you get x equals 1. And really, without knowing anything about systems of equations, they've magically solved a system with three equations. And I tell my students, this is your ideal system right here. This is called a triangular system. That's where you get this 3 variables, then 2 variables, then 1 variable. Okay, they call it a triangular system. This is why they call it a triangular system. And what you do is one variable will be solved for. And then you substitute that into the one with 2 variables, and now you have 1 variable, and you solve for that one. And then you substitute them into this one, and you solve for that one. That's called back substitution. If you were to take a course in linear algebra, they talk about how to make this system a triangular system. It's got a special name in linear algebra, but for all intents and purposes, it's a triangular system. A reduced row echelon form is what they would call that in a really fancy higher level math class. But in just a college algebra or pre-calculus class, I tell my students it's a triangular system. And this method of taking this answer and plugging it in, and then taking these answers and plugging them in, is called back substitution. And so if you can make a system look like this, the back substitution is very simple, and you get your 3 answers and you move on with your life. Okay, so that's a simple system. It's already triangular in form, and we can solve it with back substitution. So what I want to do now is I want to take a system like this and say, okay, guys, can we take this system and make it look like that first one? And the answer is, if you look at your first system, you had one equation, had 3 variables. Okay, so you had 3 variables, and then you had 2 variables, and then you had 1 variable, right? So that's what we need. I need one of those, I need one of those, and I need one of those. Okay? And I look and I say, well, I've got 3 that have 3 variables. So I come up here and I put a check mark. 3 variables. I got that. I need to create these 2. Okay? I need to create the 2 variable and the 1 variable. And I do that using the elimination method. So I take this guy and I say, okay, let's take these 2 equations right here. Okay? And I'm going to pick these 2 because I can get rid of y. Okay, I'm going to pick these 2 because I can get rid of y. So I say 3x minus y minus 3z equals negative 2. And x plus y plus 4z equals 13. And I add those together. And when I do that, I get 4x. These guys go away, and then I get negative 3 plus 4 is plus 1z equals 11. Okay? And I just did all of that off camera frame, sorry. And I get 4x plus z equals 11. Now I have a 2 variable equation. Okay? But to get a 1 variable equation, I need another one of these. So I say, okay, what else can I do? Okay, so here I've got, and I like to circle them. So I've got a 2 variable equation, and I circle it so I can find it in all of my work. Now I come back over here and I say, okay, what else can I do? What else can I get rid of? Now keep in mind, I got rid of y here. So whatever I do, I have to get rid of y again. So I say I can take these two equations here and here, and I can create something, can't I? Okay, I can create something. So I take this top equation, which is x plus 2y plus z equals 3. And I take this equation and I'm going to multiply it by 2. I'm going to multiply this entire equation by 2 so that the y's go away again. So 2 times 3x is going to give me 6x. And 2 times negative y is going to give me negative 2y. And that's going to go away, which is what I'm shooting for. And 2 times negative 3z is negative 6z. And 2 times negative 2 is negative 6. And so I'm going to add those together. So I get 7x, these guys go away, and z minus 6z is minus 5z, and then 3 plus negative 6, I can't see because of my little silly arrows, but negative 2 times 2 is, or negative 2 times 2 is negative 4. I don't know where my brain is this morning, I'm sorry. Negative 4, not negative 6. See, you make simple mistakes when you hurry, so you have to be very careful. And 3 minus 4 is negative 1. Okay, 3 times negative 4 is negative 1. And so now I have a second equation with two variables. Okay, I have a second equation with two variables. So I have this guy has two variables, and this guy has two variables. And now I'm going to take these two, this one and this one, and I'm going to put them together to make an equation that has one variable. And the easiest one I see to eliminate is z, because I've got a plus 1z. It's really easy to multiply. So I'm going to take this guy and just copy it. So I get 7x minus 5z equals negative 1. And I'm going to take this guy and I'm going to multiply it by 5. Okay, so times 5. Okay. And 4 times 5 20x, and 5 times 1 is plus 5z, and 11 times 5 is 55. I'm going to add those together, and when I add those together, if I'm neat and actually make an addition sign here, I get 27x. These guys go away, and 55 minus 1 is 54. Okay? So now here's what I have. I have an equation with one variable. I have two equations with two variables. And I have three equations with three variables. Any combination of these that has one equation with one variable, one equation with two variables, and one equation with three variables will give me my solution. So let me give you a simple concept here. When I do this in class, I tell my students, pick one of these equations. It does not matter which one you pick. And that's very hard for students to understand, but it really doesn't matter. So I'm going to just take this top one, x plus 2y plus z equals 3. So x plus 2y plus z equals 3. Okay? And then pick one of these guys, this one or this one. It does not matter which one you pick. I'm going to pick this one, 4x plus z equals 11. Okay, so 4x plus z equals 11. Okay, and then of course you have to use this one because it's the only one you have with one variable. So 27x equals 54. Okay, now if I were to take this system and try to, so this is my triangular system, and of course if I take 54 and divide it by 27, what am I going to get? I'm going to get x equals 2. That's pretty simple. All right, well if I plug in x equals 2, 4 times 2 makes 8. Subtract it from 11, what do you get? Z equals 3. And then of course if I've got 2 and 3, right, so that's 2, and that's 3. 2 plus 3 makes 5. Subtract that, right? You get negative 2, so you get y equals negative 1. Ta-da! Now, sometimes people look at me and they say that this can't be possible. You can't just randomly pick some equation from this paper and it work. Well, let me just show you that it does, okay? So here are my answers. Let me go back and let's say I'm a different student. And instead of picking this first equation, let's say I pick this third equation, x plus y plus 4z. So x plus y plus 4z equals 13. Okay, so I'm going to take that equation, 3 variables. Now, last time I picked 4x plus z. Last time I picked this one. This time I'm going to pick this one. Okay, so this time I'm going to pick 7x minus 5z equals negative 1. So 7x minus 5z equals negative 1. And of course I have to pick this third one because it's the only equation I have with one variable. Okay, so here's my triangular system. Notice how different this one looks. I'll zoom out just a little. Notice how different this looks. The first equation is different. The second equation is different. The third equation is the same, and that's always going to be true. But this second and third equation came from that original system. Okay, so it doesn't matter. And let me show you that it doesn't matter. Now, obviously, if we solve this for x, we're going to get 2 again because we're going to divide by 27 and get 2. Okay, so 2 times 7 is 14, right? So if we move that 14 over here, subtract 14, we get negative 15. You divide by negative 5, what do you get? You get z equals 3. All right, negative 15 divided by negative 5, positive 3. Look at that. Same answer. Completely different triangular system. Same answer. Okay, then we take the original equation here. We get 2 here. We put 4 times 3, which is 12. Okay, so 2 plus 12 makes 14, right? Subtract 14, we get y equals negative 1. Okay, same exact answer, no matter how you do it. And I tell my students, if you have 3 equations with 3 unknowns, you always want to go through the trouble of making a triangular system. And the fun thing is, I took these 3 equations and I got rid of y and I made this, and I got rid of y and I made this. If you were to take this same system, just play around and say, okay, well, he got rid of y. I'm going to make my equations with 2 variables here and here by getting rid of z. Your two variable equations would look very different than mine. You would still get the same answers in the end unless you make a math boo-boo. So it's a lot of fun to do. It's a really simple solution technique. It's one that I don't see in a lot of textbooks for undergraduates. They tend to be, oh, hey, here's an advanced textbook in linear algebra, and here's how you solve a system. And it's really a simple method that I think you should know earlier in mathematics. So if you have any questions, please let me know.